find the inverse function of f of x equals 6 minus x. First, we need to write this as y equals 6 minus x. Second, we need to switch x and y, which turns this into x equals 6 minus y. And then we need to solve for y. Once we have y in terms of x, this is the equation for the inverse function of x. To get y alone, we can subtract 6 from both sides. This gives us x minus 6 equals the opposite of y. And then to get y alone, we need to divide both sides by -1. X divided by -1 is going to be the opposite of x. The next term will be positive because a negative divided by a negative is a positive. So that'll be plus 6, and then that equals y. And so this gives us the equation for f inverse of x. It is the opposite of x plus 6. But I want to point out something interesting. If we switch the order in which we write these terms, we can rewrite this inverse function as 6 minus x, which happens to be the exact same as the original function. In this case, both the function and its inverse are the same. It doesn't happen very often, but it is possible. Let's take a quick look at the graph of these functions to see why. We know the graph of y equals 6 minus x is a line that has y-intercept 6 and slope -1. So the line is going to go through these points, and it's going to look rather like this. And we know that if we want to look at the graph of a function's inverse, we need to take the graph of the original function and reflect it about the line y equals x, which I'm drawing right now. So this is our original function, f of x equals 6 minus x. To find the graph of the inverse, we need to reflect this across the line y equals x. But if we take the points on this graph and we reflect them, they end up being on the same exact line. And so when we draw this line in, we can see that the graph of the inverse function is the same as the graph as the original function, which of course means that the equation for the inverse function will be identical to the equation of the original function. Interesting.